Welcome back to my channel Siddhanath Nishandar. In previous videos, we see how to improve the efficiency of gas turbine by method regeneration, reheating, and the intercooling. Okay, today we discuss the gas turbine with regeneration, reheating, and intercooling. Okay, this slide of these videos is quite interesting. Where we going to modify all the methods simultaneously on open cycle gas turbine. Please subscribe my channel. Okay, let's start. Okay, before combining, I again revise the short what is meant by regeneration. If we see in regeneration, we preheat the air. Okay, we preheat the air before entering into the CC, and the preheat of air is takes place because of the exhaust gas is going to the waste to the atmosphere, where we going to utilize that waste heat recovery. Okay, so result in that the 2 to 3 the temperature rise before entering in the combustion chamber, which consumes fuel. That is the regeneration method. Okay, in reheating, the expansion of gas is carried out in two stage. Okay, if expansion is carried out in single stage, okay, what happen? The work done is reduces, but that expansion is carried on two stage. Okay, we see this hatching area indicates there's increase in work done. We also go to the my previous videos where I detail explain. Okay, just I revise because of further slides we're going to combine these methods, so again revise here. Okay, in reheating, the work done is increases, the expansion is carried out in two stages. In intercooling, you see, we know that the what amount of power developed by the turbine is consumed by the compressor is around 55 to 60%. So there is to improve the overall plant efficiency or overall work done of the turbine is increases only when if you reduce the compressor work is possible when we compressing the gas in single stage, that gas we compressing in two stages. Okay, rather than single stage compressing, we put here two stage compressor with intercooler is very important. The two stage compressor with the intercooler is plays very important role of the intercooler, so that the compressor going to reduces because of the 2 to 2 dash is line is more as compared to 3 to 4 dash. Okay, and we go to the previous videos we discuss in detail the intercooling. Okay, we just conclude that with the help of intercooling, that is we use two stage compressor with intercooler, result in that the reduces compressor work and the overall turbine work is going to increase. Okay, now see here, gas turbine with the regeneration, reheating, and the intercooling. Okay, we're going to add all the modification where we use intercooler. See here. Okay, intercooler is there, regenerator is there, and if you see, the turbine is also there. If we see in previous videos, what is the role of, we start with the regenerator. Regenerator is utilize the waste heat recovery from the turbine. Okay, see there is the we carried out the expansion of the gas in two stages. From the after the two stage or the final stage of the turbine, the exhaust gas released to the atmosphere. Okay, and that heat we going to recover here, and that heat we going to recover. And we know the function of regenerator, which preheat the air before entering into the CC. Okay, after compressor, okay, the compressed air before entering to the CC is preheat with the help of regenerator. Okay, then you understood the what is the role of regenerator when combining these all the three methods. Okay, before that regenerator we focus here now compressor. Okay, what are the stage in compressor? A two-stage compressor used with the help of intercooler. This is a low pressure compressor, and this is the compressor to it is the high pressure compressor, and is provided with the intercooler. So result in that the compressor work is going to reduce. So it is the intercooling. This is the regeneration method, and after combustion, okay, that combustion is carried out on two stage. It is the high pressure turbine and it is the low pressure turbine. Okay, so it is called as a reheater. So the expansion is carried out in two stages, and after expansion of first stage turbine, that combustible gases add some heat, and that combustible gas again expand in the second turbine. Now that all the methods or all the TS diagram we studied previously separately. Now what effect on TS if you're going to combine all the three methods? Okay, let's start with the first, intercooler. Okay, now we're going to change pen color here, ink color taken dark blue. Okay, see, if you see in intercooler, now 1 to 2, okay, before that I rub this hatches for better understanding, eraser. Okay, now let's start with the intercooler. Okay, now 1 to 2 is the compression process. Here see, 1 to 2 is the compression in low pressure turbine. So 1 to 2 is the compression. Okay, 2 to 3 is the intercooling process, and we know that the intercooling is carried out at constant pressure. So it is the intermediate pressure, and on TS diagram you know the nature of, on TS diagram we know the nature of pressure lines like that. Okay, so 2 to 3 at constant pressure there is a drop in temperature, such a way that T1 is equal to T3. Inlet temperature of low pressure compressor is equal to the inlet pressure of second stage of compressor, that is a high pressure compressor, that T1 is equal to T3. That concept is also called as a perfect cooling. Now the temperature of the gas is going to cool, that is atmospheric pressure, that is initial temperature T1 equal to T3. Then 3 to 4 is again compression. Okay, that 3 to 4 is again compression in a second stage, that is a high pressure stage or a high pressure compressor, and is a low pressure compressor. Okay, we know, we will also discuss in the previous videos, we see there. Then 4 to 5 is the heating. That 4 to 5 the heating process is carried out in the regenerator, and that heat is given by that heat loss by the exhaust gas of the turbine. See here 9 to 10, if we see 9 to 10 is the exhaust process, it releases to the atmosphere. Okay, and going to the, before going to the release is that heat is given to that compressed air. So the 4 to 5 is the regeneration method. Then 5 to 6 is the combustion process, addition of heat takes place, so 5 to 6. Then 6 to 7 is the expansion in low pressure turbine, which takes place isentropically, so it is line straight 6 to 7. 7 to 8, if we see, there is again addition of heat is carried out in reheater, such a way that that temperature T6 is equal to T8. Where is temperature? T6 is the inlet temperature of turbine 1. Okay, before going to the turbine 2, that T8 temperature must be T6 is equal to T8, and that temperature achieved with the help of reheater. And again 8 to 9 is the isentropic expansion. Okay, if you see isentropic expansion in the second stage of turbine, that is the low pressure turbine. 9 to 2 is the reduction of heat is carried out in the regenerator, and 10 to 1 again that heat is released to that atmosphere. So we're going to combine all the methods, then how to develop we discuss here. Please subscribe my channel. Thank you.